Good evening. Tonight we mourn the loss of a dear friend, my rechargeable lithium-ion Dremel, which unfortunately let the magic smoke out the other day as I was cutting through a metal strap. So I initially thought that the motor was probably buggered, but actually I let it cool down a bit and I tried turning it on, and I found that the motor still works, but it spins up immediately to full speed. So I think that something to do with the speed controller is buggered. So let's take it apart and have a look. This is actually one of the tools that I use the most. It's useful for drilling, grinding, cutting, all that sort of stuff, and it's great when you don't need the power that a bigger drill or a grinder will give you. It's also it's very useful because it's so lightweight, and it doesn't because it's rechargeable, it doesn't need mains power. So we've got a number 10 Torx bit, and I'm just going to undo the 4 screws that hold the case together. One of them. Oh, and before I actually take it apart, I might just pull out this lithium battery, because we don't really want to short that out and have a lithium battery explosion in the living room. That wouldn't be very good. Come on, and out. And one more to go. So before we can take it apart, there is also the collet, or the chuck rather, which just needs to come off. That just unscrews. And there's a little screw-in plastic collar that holds the two halves of the case together, which again we can just unscrew, and hopefully it should then come apart. So we've got top section of the case there, and we've got the bottom section, which has these two little parts floating around, and I think these are something to do with the locking button. And the rest of it is quite simple, so we've just I'll just zoom that out a little bit. So we've pretty much just got our speed control knob, a PCB, which I'm assuming is a speed controller board, and we've got the motor, and we've got the main shaft just connected directly to the motor. There's no gearbox or anything like that. There's a bearing which just sits in that groove in the plastic case, and that obviously supports the shaft and prevents any side-to-side load on the motor. So hopefully that'll all just pop out like that. Now I suspect, because of the fact that when we switch this thing on it just goes to full speed and stays there, I suspect that the problem is that the drive transistor is shorted. Now, in order to allow the motor to run at variable speeds, this will have a transistor driven by PWM, pulse width modulation, and I suspect that it's going to be this one, because it's the biggest one on the board, and it's got a little heatsink. Obviously this transistor is going to be the one that does the most, so that would kind of make sense. So I'm basically just going to get, in fact I'm probably just going to get this motor out of the way. So let's just, do these just pop out like that? Yep, they do, that's nice. Let's pop those connections out. Oops, just trying to roll off my desk now. Looking at the back of the board, we've got this unknown component here which one side of it connects to the drain pin of the MOSFET on the other side, and I don't know what this part is. I've tried to read the part number off it. I suspect it might be a protection diode to prevent back EMF spikes across the motor. We've also got, obviously we've got the 2 battery terminals that connect to the lithium battery. We've got a variety of smaller components around here. I can see a couple of diodes. I can see a little, I think it's an 8-pin controller chip, and I think that's just a PWM motor speed controller chip. So going back to the front of the board, I've actually paused the video for a second to scrape away the blue silicone gunk around the pins of this chip, just so I can get easier access to it. And what I want to do is just to confirm that this actually is the problem, or at least I think this is the problem. I'll just stick that in there to keep it upright. I'm just going to measure across the legs of this transistor to see whether it's shorted out or not. So I'm going to get my meter and I'm going to stick it on the 200 ohm range. Get those out of the way. So here we are. And I'm going to get one probe and I'm going to stick it on the... Oops, this is all going wrong now. I'm going to get one probe and I'm going to stick it on the drain of the chip, which will be connected to the metal tab, and I'm going to get the other one and I'm going to stick it on the source pin. And it looks like that MOSFET might be shorted because it's reading 5 ohms. Now, just to make sure that we're not reading a diode in there as well, I'm going to put the leads the other way around. And we got the same, about 5.6 ohms, 5.5 ohms. So yeah, I think this MOSFET is our problem. I've probably got a similar one in the parts drawer, so I'm basically just going to throw a new MOSFET at it and see what happens. So I've already read the number on that MOSFET, and it's an STB. It's from ST Microelectronics, and it's an STB80NF03L, which is an N-channel 30 volt 0.0035 ohm 80 amp power MOSFET. And I think that's probably, I'm probably going to have something in the parts drawer that's similar, so I'm going to go and have a look and I shall be back in a minute. Okay, so I've just been to get some parts and some tools, and I think I found the MOSFET that's going to be sort of suitable, and it's an STP36NF06FP. It's an N-channel 60 volt 0.032 ohm 30 amp power MOSFET. Now 30 amps is a bit less than the other one, but I don't really think that the MOSFET in this is ever going to see that amount of current, because, you know, it might say 10 amps or something like that, but I don't think they're going to be pulling 30 amps out of this tiny little battery pack. So I've also got some solder and some solder wick, which I will use to suck out the old MOSFET. I've got a pair of wire cutters, and I've got a bloody great big screwdriver. And what I'm going to use the bloody great big screwdriver for is just to try and shoehorn this rivet out that's holding the old MOSFET in, because we don't really want that getting in the way. It's going to be a bit more difficult than it should be. Yeah. Just see if we can just prise it out of the way. There we go, and we've got that free of the rivet there. This is probably not the ideal way to do things, but I'm kind of lazy and I don't have the proper tools, so there you go. I'm just going to need bending back, a little tiny copper heat sink. Okay, so I'm going to flip this board back over again, and oops, that's now just fallen off. Well, that's fine, because I can sort that out later. Bend that out of the way and try and get it laid down. And just zoom in on it. You can hopefully see it. Okay. Okay, so I've now replaced the MOSFET and put everything back together. So as you can see, I've replaced the rivet that held the previous MOSFET in with a screw. Now, it is conductive, but it doesn't really matter because the MOSFET has a plastic casing anyway. So I've also reconnected the motor. So let's put it all back in the case and let's see if it works. So when you're putting this back together, this little thing, this little metal pin, is part of the locking mechanism, and it goes into the locking button like that, and then you just pop the little metal half clip in over that, and you get your motor and circuit board. So it's obvious where the circuit board goes because there's a cutout for the speed control pot. Your little metal clip clips in like that, and making sure that that's fully in its hole. Just pop these battery terminals in, and we should just be able to pop the other half of the case back in on top, like so. Then we get the plastic collar and screw that off to hold the case together, and we pop our screws in like so. Oops. And button it back up again. And now if we pop the battery back in, and pop the, oops, I'm not having a very good night tonight, pop the chuck back on, like so, and we should find that it works. It's promising. There we go, so we now have a Dremel with functioning speed control again. Now, I'm not entirely sure about that MOSFET that I put in, mainly because of the current rating and the heat dissipation of it, because it's in a plastic case. So what I might do is pull this apart again at some point soon and replace the MOSFET with the correct one, if I can get hold of it. But yeah, at least we know that that fix works, so I'm quite pleased with that. I do use this tool quite a lot, and it's nice to have it working again. Thanks for watching.